First of all, thank you everyone, and especially Brevian to organize this conference, as well as thanks for the Dr. Thomas give us really interesting like topics on the nano skills, circulars that we can utilize in the wide areas. So today, for my topics, I want to talk about recycling and utilize about the polyethylene waste to generate energy through the coal combustion process. So generally, I will first talk about that. What is the polyethylene waste? Then everybody know about that polyethylene waste is the mixture about the actually the polyethylene manure with the when we grow the chickens. Actually, we need apply the bedding materials, make the chickens more comfortable, as well as they have no like the high moisture content and the other chemicals come out of, about the polyethylene to like have the burn about the chicken feed. So normally we will collect some sawdust, rice husks, and other materials. Depend on the reasons, we will apply different type of the bedding materials. They will mix together to form the polyethylene. Normally we call it. So in the United States, generally we already have 25,500 poultry litter farmers in the United States, and each farmers have one farm, and the farm will be have 3 to 4 houses, and the house size is normally like 42 feet to 500 or 40 to 400. So dependent on the sizes, then the amount of waste generated is different. So in 2012, we figure out that here in United States, around 8.4 billion broiler chickens is in the United States, and it was increased to the 8.9 billion in 2017. And now is last year we recently got the data is 9.2 billion in 2019. So using this data, we estimated about there will be 1.1 to 1.4 tons of polyethylene per 1,000 birds. Then we will have 9.24 to 12.88 million tons of the year polyethylene will generating annually in the United States. Actually, United States is the one of the largest broiler chickens producers around the world. It's the second. Brazil is the first. So there's a lot of waste generating from the poultry farms. So where are we gonna use it? So normally, as we know it, first we will clean out this waste materials from the farms. Then we will store it in the storage. After it, most of this poultry litter will be transported to the adjacent farms. Then it will be applied to the land as the fertilizer, because poultry litter have the high concentration about the nutrient, phosphorus, as well as potassium. So this can be the really good fertilizer for the farm. But the problem here is like nowadays there is a lot of nutrients already applied on the farm fields. So the nutrient will be run off through the rain. So as you can see in the pictures, what happened for this problem is when this kind of nutrient applied to the waters, there will be a lot of high concentration about the nutrient inside water. So this will be caused about the algae blooms. So they will take out all the oxygen in the water. So this will be automatically to kill the fish and other aquarium in the waters. So our research objective here is like we will first review and compare some alternative method rather than the land application about the poultry litter, how we can utilize this kind of poultry litters, how we can recycle this, and better to manage about this kind of waste. Second objective about this research is actually is generating electricity through the coal combustion about the poultry litter with the natural gas. later I will talk about why we should have the cold combustion process. Third is like after this kind of electricity generation process, we will still have some residue heat from the combustion process. Then we will using some heat exchanger to collect the residue heat from the flue gas and generate release to the hot waters, which can be utilized in the farm. Then last objective about this study is the cost comparison between the energy generation and the land application about the poultry litter. We will see that in the cost side, which is more better for the utilize the poultry litter. So what kind of alternative technology is in the poultry litter conversion? First is the composting. As we know, is we will have a big areas. Then we will just put a collected poultry litter under there. Then there will be an aerobic degradation about these materials. Actually, this will be takes a really long time, 4 to 6 weeks. Then it will be reduced moisture inside the poultry litter, so we can easily apply to the land field. But this process is really lose a lot of nitrogen, which is nutrient. So it will be not very effective as a fertilizer. Another problem is outdoors, as well as high ammonia will be generating from this process, which will be cause the climate change. Another process we also talk here is the gasification process, which is using the high temperature, about 700. Then we will inject the oxygen, heated oxygen, or the steam in this process, trying to make the synthesis from the poultry litter, which include the carbon monoxide, hydrogen, and carbon dioxide. This process also cost a lot of like the cost to generate the high heated like the steam. So next third alternative technology here, we also have the pyrolysis and combustion. Actually, all pyrolysis, combustion, and the gasification, they all have the different temperature ranges. Pyrolysis means that this temperature will be lower than the combustion. We will using the really warm conditions, trying to have the thermal decomposition about these materials, and this will be generating the biochar. As we know, when we have some barbecues, there will be some like the biochar like from the wood. But actually, we can also do the similar process about the poultry litter, because this is the mixture about the sometimes it's sawdust or rice husk. There is also some this kind of materials can be generating the biochar from this process. So this problem is that there will be high investment cost about the pyrolysis devices, which need a large scale. So another is the anaerobicization. So this is the biological process. We inject the microorganism inside there, and we will using the environment of no oxygen inside there. So we will generate biogas and fuels from here. But this process, the problem is inside of the poultry litter, there will be the high nitrogen inside. So ammonia nitrogen will be inhibited this process. So the conversion process of anaerobic digestion for the poultry litter is not very efficient. So the combustion is the most simple thermal like chemical methods, and also used really widely in different kind of biomass materials, same as poultry litter. But what's the challenge here to once we want to burn the poultry litter itself inside here is from the table 1, we can see about the composition about the poultry litters. There will be the, as you can see in the column, we saw that the poultry litter have the wide range about the moisture liter moisture content from the 5 to 43%, and the average about the poultry moisture content is around 80%. So this will be the lowering the combustion temperatures as well as reduce the combustion environment to have the stable combustion process. Another problem will be the slagging and corrosion because of the polyester also have the high concentration about the K and the Cl. The solution for here is like we need to increase about the combustion temperature during the combustion process. That will be avoid to have this kind of slagging or corrosion through the combustion process. So we come up with idea is the other research groups mostly is using the biomass plus the coal combustion process to increase the heating value as well as improve the combustion process and lower the combustion emissions. Next slide, we can see that there is already have several research groups trying to study about the coal combustion process about the polyester with the coal. So they are trying to test about this combustion process using the different range of different operating conditions, such as the different ratio about the air and the fuel, which means the air and the polyester mixing ratio. So it will be determined about the how many emissions will be come out from the combustion process. And also they will have the different ratio about different layer about the air injections. So they will apply to the secondary air in the combustion chamber, which will be provided additional airs in the secondary air, means the middle about the combustion chamber, that will be helpful for the volatile matter during the combustion process. Unburned volatile matter will be mixed with this kind of secondary air injection oxygen. Then they will have the complete combustion process to reduce the unburned particles, such as the carbon dioxide. But recent result still there will be some challenge about the high sulfur dioxide as well as nitrogen dioxide, because of the natural there will be high concentration about the nitrogen and the sulfur in the coal materials, and also there will be some mercury, lead, and particulate matter emission from the coal and the polyester coal combustion process. So our research group is here is like trying to burn this polyester with the natural gas, which have a better performance than the coal. So we will in our previous test we investigated about some operating conditions, how it affect on the emissions. We also test about the different ratio about the secondary air injection, as well as the different height about the secondary air injection. Using the data, we predict the combustion efficiency about this process. But this is still, there is not enough study that we can full generate the energy from this process. This burning process will only provide us about the flue gas, which is heat. Then we need to think about how we can using this heat from the flue gas. So our idea is generating the electricity as well as to extract this amount of heat from the flue gas, transfer this to the cold water and generating hot water, which can be also one form of the end product which can be utilized in the farms. So this is the actually the sustainable life cycle about the polyester in the polyester farm. So Dr. Thomas also mentioned how we can have the zero waste. So our idea is the zero waste from the polyester farms. So when we have the polyester from the polyester generating from the houses, then they will move to the shed. Then we will have our developed combustion chamber here, which implement about the Stirling engine, which is the small scale about the engines, can produce electricity from the burning process. Then we will have integrated about the shell and shell and tube heat exchangers to the flue gas side to extract that residue heat, generating the hot waters. And after the burning process, as we know, there will be some fly ash, which is the residue about the combustion process. This is the high concentrated nutrient. Even this is the reduced volumes, so it easy to the transport from one side to another side, reduce the transportation cost. So so this electricity and hot water and the biochar, also we sometimes called biochar of fly ash. How we can utilize this? This will be applied to the cropland. Then this cropland will be grew the feeding materials for the chickens, as well as the hot water will be utilized for the space heating in the poultry litter houses during the cold seasons. Then the electricity will be the supply to the fan and the lighting system on the poultry litter farm. The fan and the lighting is the most highest, like the electricity consumptions during the chicken growing seasons, because we need the extract the ammonia production for the poultry litter houses. That will be help even growing, have the better growing for the chickens. And also the lighting will be adjusted to control the chickens to eat the materials. So next diagram is the schematic diagram about our systems. So as I mentioned, this is the combustion chambers we developed in our research groups in the lab. They will have the 3 different layers about the secondary air injections, as well as 1 primary injection from the bottoms, which creating about the fluidized combustion, like the combustion inside about the chambers. So this will be improved about the combustion efficiency and reduce emissions. So the Stirling engine, as you can see, is injected in the lower part about the chambers, which can be absorbed the most heat, the most highest, like the combustion temperature will be happening in this height. So we inject this Stirling engine in this part, trying to create electricity from here. After the burning process, this will be held the shell tube heat exchanger between the cyclone and the combustion chamber to collect this residue heat. So this is the diagram that we fabricated the shell tube heat exchanger in the laboratories. So our concepts here is we applied the twisted shape about this heat exchanger, trying to create the turbulent flow inside these shells that will be increase the heat transfer process to maximize the heat utilization from this process. So processed hot water will be the transfer to the radiators. So in our laboratory, we install these radiators inside the empty trailers to mimic the heating process about the poultry litter houses space heating process. So this is the diagram about our like the test result about the Stirling engine performance. We evaluated this electricity generating process depending on the water flow rate about these engines, as well as the combustion temperature inside the chamber, which affect the head temperature about the Stirling engine. As we can see, definitely when the temperature increases, this will be the higher amount of the electricity generating from this process. Through testing about the wide range about 9 to 19.5 liter per minute water flow rate, we find out that the 13.1 liter per minute water flow rate and 10.4 liter per minute will give us the maximum electricity generation about the 900 watt at the head temperature about the 584 degree. Then our test also, we trying to perform the different type about the shell tube heat exchanger test. We test about the different different directions. We test about the concurrent direction about the heat exchanger, which means the flue gas and the water direction will be the same. And the countercurrent, which is the flue gas, will be coming to this direction, and the hot water will be coming at the object direction. So our result indicated that the countercurrent direction will be held higher performance than the concurrent directions. Also, this shell tube laboratory fabricated shell tube heat exchanger give us the capability to generating the heat water around the 60 Celsius, as well as have the we using heat transfer equations to calculate that how much heat can be captured from this process. We figure out there approximately 25 to 32% about heat can be captured to the water, and supplied to the trailer. Then the trailer temperature increases from 12.7 to 29.4 Celsius. So this combustion process, we performed around 3 hours. So 3 hours, we feed about the between 15 to 20 pound per pound poultry liter, which can heat the trailer house around to the 30 Celsius. And we also analyze about the fly ash from this combustion process. We got the different phosphorus, potassium, as well as the calcium content. So there will be around 16% about the nutrient still remaining in the fly ash can be utilized as a nutrient for the cropland. So after this kind of cold combustion process, we trying to compare about the cost about using it as the fertilizer in the land, or second process is we will using cold combustion process to generating electricity and hot water from this process. As we can see, we assume that 1 ton about the poultry liter, and there will be have 62 pound about the nitrogen inside there, and 30 pound about the phosphorus, and 50 pound about the calcium, potassium inside about the poultry liter. Then according to now the marketing fertilizer price, we calculate about there will be $22 revenue we can collect from the nitrogen, and $12 from the phosphorus, and $15 from potassium inside the poultry liter as the fertilizer. So land application, we can have a value about $49, close to $50 per ton about the poultry liter. Literature reviews also show a wide range about $36 to $107 because nutrient content will be affected by the growing different practice we using there, different seasons, as well as how depths the clean out will happen inside the poultry liter, as well as what type of the bedding materials we applied inside the poultry liter house. Then next we will using the heating value about the poultry liter, which have the 14.08 megajoule per kilogram in the poultry liter. We calculate about the total heat generating from the poultry liter 1 ton, and we assume that we use according to our like the hot water generation and the electricity generation. We know at least we can capture 30% about this energy through this cold combustion process, which will give us around 1,064 kilowatt per hours we can generating from the 1 ton of poultry liters combustion process. According to now electricity cost, which is 13 cents, 13.19 cent in United States, we can have around and the revenue about 140.39 per ton. So this comparison data show us there is a big revenue for the farmers if they using per liter as the core combustion process in their farm to generating more revenue for them. We do the case study about 3 to 4 farms, which each farm have the 120 tons per houses, and total value about 330 to 480 tons. We just assuming that they will using 50% about this per liter, then they can have the total revenue about 25K to the 33K for their revenue. So this is really big additional money they can making from to grow the poultry, grow the chicken. So this is really the energy value they can create it from this process. As we all know, is a low income for the growers, which will be get the contract from the poultry industry. They can utilize some system or combustion process which we proposed here to increase their revenue, and this will be the really good options for them. So this is the conclusion about our studies. We show the co-combustion process in our laboratory skills. We can have the around 900 watt electricity we can produce from our system with the hot water temperature around 60 and increase the house temperature to the 29.4 Celsius. Then this study provide actually the pathway we can utilize the poultry litter as the zero waste from the poultry litter farming process, as well as the energy production cost analysis show us that there will be the big revenue from the energy production from the 1 ton of the poultry litter compared with the land application as the fertilizer. So our future study will be continue to perform the cost analysis using the wide range about the heating value, because depend on the different moisture liter content, we will have the different heating value about the per liter house or per liter. So this will be affect how many energy we can extract from the per liter house, as well as the production rate. Depending on the per liter farm sizes, we can give the rough estimate about the per liter. Then this will be give the different revenue for the per liter farmer, like the chicken growers. Then also we will also using the energy fuel cost to compare about that which approach will be viable for the poultry litter farmers. So poultry farmers. So the others, we will also search about some incentive programs, like the federal tax credit. Here we can apply it if we using this kind of biomass as the sources in the poultry litter farm. When we generating electricity, we can get the tax credit from federal. Another is we will also consider about in order to generating this kind of energy, we will move the chicken litter probably from one place to another place. So we can also apply some environmental quality incentive programs from the federals to give the subsidy for the poultry farms who want to using this kind of technology. Then next one is we will continue also to study about other alternative technologies which we can further develop, trying to help farmers in the United States, as well as the nationwide, who have the big broiler chickens productions. Thank you. Next slide is I will thank you for about our research group in Morgan State University, especially my advisor, Dr. Lee, as well as my colleagues here, as well as our funding agency I listed here. Thank you for your audience.
Thank you so much, Professor Quinn. That was wonderful presentation about the poultry waste into energy using co-combustion process. Thank you so much. I'll leave some time here for comments and questions. If anyone have questions or comments, you can please ask Professor Qian from USA.
So very nice talk by Professor Qian, very interesting talk. I wanted to ask you a very important question. You see, in my locality, there are a few big chicken farms. What they do is they do fantastic generation of biogas.
Yes.
And I had some meeting with these companies. They say it's a very economical process. They produce all the gases, all the energy from biogas.
Yes.
How do you compare this biogas process and this combustion in terms of cost effectiveness? And this company people said they are very happy because they generate their own energy from this biogas. And they say they have no problem doing very well and they get excellent manure fertilizer that also they sell.
Yes.
Would you please comment on this? The cost effectiveness of making biogas and then making a fertilizer and the combustion process.
Yes. First of all, thank you about Dr. Thomas, this interesting question, as well as we always collaborate with the industry people trying to see which is the best, even like the alternative technologies to using this poultry litter. As you mentioned, biogas probably they are using the gasification, or they are using the pyrolysis, what I mentioned in the previous slide. So this kind of system actually need really large skill about the system. As I mentioned, if we have the investment, like the big investment from the government, we can build this kind of big facilities and move all the surrounding chicken, surrounding poultry litter farms waste into this centralized system, then generating the biogas. Especially biogas also have the higher cost about the purification process we need help. So if we build this kind of system as the small scale as what I mentioned as the combustion, this will be not very cost effective. So if we can have the large scale farms nearby our areas, as well as we can reduce the transportation cost, as when we in the economic views about this process, I recommend also we can probably using the gasification if we can get even the subsidy or the investment from the government side. So even I studied this kind of technologies, I also see a lot of the incentive programs as well as government support trying to see which is really best for the different reasons. So we need to analyze in different countries, in different situations.
Yes.
So
my good friend in Netherlands, you know, he has a big combustion plant, as you proposed.
Yes.
In Netherlands, in Hong Kong, in Holland, in Netherlands, they practice combustion.
Yes.
But they also talk about the pollutants as a result of, you know, the pollution as a result of combustion. Are you also looking at this aspect, the pollutants?
Yes, I didn't mention in my slide, but because I think sometimes I want to give some general, like the introduction for the readers, especially we focus about also emissions about the, as you mentioned, especially different like the carbon dioxide, carbon monoxide, nitrogen dioxide, as well as the particular matters these days, especially when you burn about the biomass. You need definitely about the PM. Everybody is focusing on that. So I also have some result about our combustion techniques, because we are trying to using about the 3 layers about the secondary air injections. So once the combustion process happen inside, they will, normally we know biomass is have the high volatile matters. So they will have the combustion process in a little bit higher position about the chambers. When they will have that process, we will try to have the excess oxygen inside there, trying to have the completed combustion. Okay, thank you, Dr. Thomas. We can have some continued conversation. Thank you for your question. I'm really interested about these kind of questions. Yeah, thank you.